discuss about ED pathway. Introduction. Entner-Doudoroff Pathway is alternate series of reaction that catabolize glucose to pyruvate. Entner-Doudoroff pathway was first reported in 1952 by Michael Doudoroff and Nathan Entner. They are the scientists. There are few bacteria substitute classic glycolysis with ED pathway. They may lack enzyme hence essential for glycolysis such as phosphofructokinase 1 type of bacteria using the ED pathway. This pathway is generally found Pseudomonas, Rhizosome, Acetobacter, Agrobacterium and few other gram-negative genera. Very few gram-positive bacteria have this pathway with Enterococcus faecalis being a rare exception. Most organisms that use the pathway are aerobes due to low ATP yield per glucose, such as Pseudomonas. The genus of gram-negative bacteria, Acetobacteria, and genus of gram-negative bacteria. Example of the bacteria using the ED pathway: Pseudomonas, Acetobacter, Agrobacterium, Rhizosbium, E. coli, Enterococcus, Zymonas species. These are some examples of the ED pathway. Features of ED pathway. The pathway occur both aerobic and anaerobic condition. Occur in prokaryotics only. It occurs cytoplasm, pyruvate and glycerolate 3-phosphate produced from the glucose by ED pathway. Next, ED pathway. It occurs only in prokaryotic and it uses 6-phosphogluconate dehydrates 2-keto-3-deoxyphosphogluconate aldolase to create pyruvate from glucose. ED pathway also has net yield of 1 ATP of every glucose molecule processed, as well as 1 NADH and 1 NADH pH. By comparison, the glycolysis has net yield of 2 ATP and 2 NADH for every 1 glucose molecule is processed. This is ED pathway cycle. Glucose 6-carbon is converted into glucose 6-phosphate 6-carbon. At the time, ATP converted into ADP. Next, glucose 6-phosphate is converted into 6-phosphogluconic acid 6-carbon. Removal of water. At the time, 2-keto-3-deoxy 6-phosphogluconic acid 6-carbon also present. Next step divided into two. One is pyruvic acid, another one glycerolate 3-phosphate with help of the enzyme KDPG aldolase. Glycerolate 3-phosphate 3-carbon converted into pyruvic acid. At the time 2NAD converted into 2NADH plus 2H. This glycolysis same step. At last, glucose is converted into pyruvic acid. At the first, glucose phosphorylated to glucose 6-phosphate with the help of the enzyme hexokinase. Second, glucose 6-phosphate is converted into 6-phosphoglucolactone with the help of the enzyme glucose 6-phosphate dehydrogenase. Aldolase enzyme is converted into 6-phosphogluconolactones to 6-phosphogluconate. 6-phosphogluconate undergoes dehydration reaction catalyzed by the 6-phosphogluconate dehydrates to form 2-keto-3-deoxy-6-phosphogluconate KDPG. KDPG split to form the pyruvate and glycerolate 3-phosphate. It catalyzed by the KDPG aldolase enzyme. Glycerolate 3-phosphate is then metabolized by the glycolysis to form pyruvate. At last, final glucose is converted into pyruvate. Significance of ED pathway. This pathway used to two specific enzyme 6-phosphogluconate dehydrates and another one enzyme KDPG aldolase are used to ED pathway. The pathway generate 1 ATP, 1 NADH and 1 NADPH from one glucose molecule. Okay guys, that's all about ED pathway cycle. If you ask any question, you ask in comment section, I will reply immediately. Okay guys, bye bye, thank you.